Okay, problem 67 now on page 476, still under the category of establishing trigonometric identities. You are assigned problem 66. And one thing I like about this bank of problems from, I think it's 21 through maybe 104 on the pages 476 and 77, is as you translate down through them, they get a little bit more, they get increasingly complex. And maybe these first three problems are a good example of that because the first two just took one step, I think. This one's going to take a little bit more. And as we kind of take stock of what we've got here, I always ask you to do that. I'm going, yikes, I got a secant, a tangent, a cosine, a cotangent. I've got 4 of the 6 all-star functions there that I've got to deal with and show that somehow this is equal to this. So what are we going to do? One thing a lot of people will recommend that you do is right at the outset, you just convert everybody to sine and cosine. Not necessarily a bad idea. It will give you a little bit of direction. If you continue to always do that, it will sort of rob you of facility with some of the other manifestations of these identities. The best example I can give you is sine squared plus cosine squared is equal to 1. You have to remember that. But it sure makes your life simpler if you remember that tangent squared plus 1 is equal to secant squared. Exactly the same identity, only it's cast in tangent and secant squared. And if you divide through by, if you divide sine squared plus cosine squared equals 1 by sine squared, you get 1 plus the cotangent squared is equal to the cosecant squared. So there's a second identity, essentially the same as the basic sine squared plus cosine squared equals 1. But cast in terms of 2 of the other functions. Having said all of that, I'm going to do just what I said here, and I'm going to turn all of these functions into their cosine sine counterpart. So a secant is 1 over the cosine. A tangent is sine all over the cosine. Down here, a cotangent is the cosine all over a sine. And a cosine's a cosine. And why did I do that? Just I'm making use of the reciprocal properties. Okay, now it gives you maybe a little direction as what to do. You've got a mess here. Let's start to clean it up. And in fact, let's clean it up by getting rid of all the fractions. And the way I would do that is multiply the top and the bottom by cosine. That'll get rid of these cosines in the bottom. And then I'm going to multiply the top and the bottom by sine. So if I'm going to multiply every term by sine cosine, what I'm going to get, sine cosine times this is going to produce a sine. Sine cosine times this is going to produce a sine squared. Sine cosine down here is going to produce a cosine squared, and sine cosine here is going to produce a sine cosine squared theta. There's a theta there. So this is multiply top and bottom, top and bottom by sine theta cosine theta. Perfectly legal operation there. Now, let's do some factoring. So the way this works so far, this is equal to this. All I did was use the reciprocal properties. This, in turn, this equals this is equal to this by virtue of multiplying the top and bottom by sine cosine. Now let me just factor a sine out of the top. And I get 1 plus a sine theta. Yeah, sine plus sine squared is sine times 1 plus sine theta. And I'm going to factor a cosine squared theta out of the bottom. I'm going to get 1 plus sine theta. Okay, so this is factoring. Okay, I'm just factoring out a sine, perfectly legal thing to do. I'm running out of space, but now I've got 1 plus sine theta and 1 plus sine theta on the top and the bottom. Provided theta does not equal pi, because, 3 pi over 2. 3 pi over 2, the sine is equal to 0, and I've got an undefined quantity in that case. But I'm not gonna hold you to that. I'm just gonna say I got 1 plus sine divided by 1 plus sine. Let's cancel it. Let's get sine theta all over cosine theta squared. Let me write that as sine theta all over cosine theta times 1 over cosine theta. And let me write that as tangent theta. There's a tangent theta times a secant theta. There's a secant theta. And if I kept that on the page, we are done. And by about a centimeter I did.